Hi everyone, welcome back to another video. This is finally round 2 of Codeforces and we're going to solve the third problem, that is MEX repetition. So the problem is very simple. They are telling that you will be given an array which is like pairwise distinct. Pairwise distinct means there are no duplicates in the array and the integers can be from 0 to n numbers. Then they are telling to consider a following operation where we are consecutively taking all the index of an array, the corresponding values, and take all the values and find the MEX of that number and replace that MEX with the number that is taken. So what is meant by MEX is it is defined as the smallest non-negative integer x that did not occur in the array. So for example, they gave MEX of 0, 2, 2, 1, 4 is 3. Why? Because 0 is smallest, 1 is also smallest, 2 is also smallest. What is the next smallest? That is 3, but 3 is not existing in the array, so we are telling as 3. What is 1, 2? 1 is existing, 2 is existing, 3 should ideally come, but why did 0 come is they told distinct integers can be from 0 to n and smallest non-negative integer. Smallest non-negative integer is 0 here, so that's why MEX of 1, 2 is 0. And one thing that you may get confused is MEX of 0, 2, 2, 1, 4. This 2, 2 is not a valid input because they just gave this as an example, and this should not be confused with the actual problem. In actual problem, all the numbers are pairwise distinct. So they are telling that after performing k such operations, what would be the output. So let's understand with the help of an example so that it will be more clear. So let's say, let's take this is the A array and n value is 3. 3 numbers are there in the array and k value is 1. If we perform this operation, it is 1 value of k. So what did they say? Take the first index, we take the first index and find the MEX. What is the MEX? It is the smallest non-negative number. What is the smallest non-negative number here? That is 2, right? 0, 1, 2 is missing here. So 0 should be replaced with 2. 1, 3 directly you write. Okay, now first number is processed. Now take the next number. What is the MEX here? 2, 1, 3. The smallest non-negative number is 0. 2, 3 directly you write. Okay. Now what is the next number? That is, these two numbers are already processed, so you can directly write it here. What is the MEX? See, 2 is there, 0 is there, but 1 is missing, right? So you can convert it to 1. Now for these three numbers and for k value as 1, these are the set of integers that we got. We need to print output, but k value can be many, like it can go till 10 power 9, but let's understand for like a small k. So for that we have some special guest outside here. Let's bring them to our dais. So these are our stars for the evening. So these guys are having different k values. So if this is k value, how will I perform k equal to 2 is, you take this output as this input, then perform the same operation again. Again, how is the operation? You take this number, find the MEX of it, 0, 1, 2. The next smallest number is 3. So you got 3, right? 0, 1 you directly do. 0. So 0, 1, 2 is missing here. So 0 has been replaced to 2. 3, 1 you directly write. Now 1. 1 is there. So 1, 2, 3. What is the smallest number that is non-existing? So that is 0, right? So you convert it to 0. 3, 2 you directly write. So similarly, you keep on going till k equal to 3. Like for example, k equal to 4 and k equal to 5. Now when they give k equal to 5, when we generate all these tables, the last final array we get, right? That's the answer. Seems so simple, right? But the problem where it happens is this our beloved constraints here, k is going till 10 power 9. So for doing an n square operation itself, 10 power 9 won't support. So obviously doing this kind of operations, how do you find min? You have to sort it and all, right? So this is not gonna work. Like lot of tables, creating 10 power 9 tables and all will never gonna work. So we have to find something, some pattern or something can exist to shorten it. So first thing that comes to our mind is, see, when we observe something clearly, if 0 goes out and if 0 goes out, another number is replaced, but 0 eventually comes back, right? It follows some kind of pattern. If 1 goes out, 1 comes in. If 3 goes out, 3 comes in the next scenario. So if you write it like same, and since we are following that, you just follow the same order again and again, right? And the numbers are also pairwise distinct, and also numbers are from 0 to n. So we can be on the assumption that the integers might repeat. We don't know, but it may repeat. We don't know. So what we did is we wrote k equal to 1 scenario, 2, 3, 4, every scenario. Now what happened is we saw something like 0 1 3 in k equal to 4. So it is quite familiar here. 0 1 3 is the first number that we got, 0 1 3. So if we get 0 1 3, if we generate again k equal to 5, this k equal to 1 and k equal to 5 are same, right? So again, if you want k equal to 6, if this is same, then obviously k equal to 6 is same as k equal to 2 also. So in this case, it is fine. So what did we understand here? We don't have to generate 10 power 9 like till k boxes. Instead of that, we can generate till k plus 1 boxes. Still assumption only, we are not sure. Okay, let's generate till k plus 1 boxes, because the value repeats after n plus 1 or n plus 2 case. So what did we do? Let's again see. Okay, table is there here, everything is ready. Okay, is it qualified to do? Then again one more constraint comes, that is n value is 10 power 5. So in this case also, if you perform like 10 power 5 plus 1 boxes, n square, it's gone. Our algorithm won't work. Now again we need to see some other thing that is still optimizing this. How do we optimize? Now we see who are the main heroes of these boxes. The main heroes or the decision makers here is this last numbers, right? These are the inputs. Then these are the inputs and these are the inputs, like that. So let's see, let's write this down. Let's see what it happens and or what it says. 201, and this is what 320, and this is what 132. This one is 132 and this is 013. Let's write down this also, 201. We know that it repeats, but 201. So what is repeating here? So the first number is 201, right? It's 201. Let's see any 201 is repeating. 201 is repeating and 201 is repeating and 201 is repeating. Why did 3 came here? That's a very good doubt, right? See, I have n value as 3 only, but why did 3 came here is they told pairwise distinct integers from 0 to n. Since it's 0 to n, 0 to 3 is how much? 4 elements. 2013, this is also 2013, 2013. It will be 3 next for sure. Now, why it repeated? Because the same number gets there, and through observation we found out. But is it the same for k equal to 1, 201, and for k equal to 2, is it 320? No, because for k equal to 1, it is 201, and what is k equal to 2? K equal to 2, it is 320. Okay, this is k equal to 3 is 132. It is totally different. We don't know what behavior it is happening here, right? It is taking 3 consecutive elements. If it's 4, very simple, you can just directly point there, but it is taking 3, so it's somewhat weird. So what happens is it is continuous. One good thing is it is continuous. So in this scenario, what we do is it is doing a clockwise operation. So if you don't know, we can write it in a circle, 2 0 1 3. Okay, so in the first scenario of k equal to 1, these are k equal to 1. Now if k equal to 2, it's 320, right? So it is 201 is here, this is 320. You see there are two numbers that are overlapping. Now k equal to 3, 132. So 132. Here also two numbers are overlapping, right? Now for k equal to 4, let me guess. So this is 132. This should be, I guess, it's 013 should be k equal to 4. 013, obviously. Now k equal to 5 is what? If this is the starting point, I should start from here. So same thing, that is k equal to 5 is same. So 5 and 1 is exactly same here. The same cycle only is rotating. So what do we do? Okay, this is forming a cycle. Now we need to know what exactly. Still we don't know. Okay, everything is under assumption. We need to run a separate test case. But these are all the observations. Now we know that the k value is getting repeated, and in one array itself I am able to get all of this. So since we know all of this, let's write this down. 2013. These are all the values, and index is what? Index is 0 1 2 3. Now we got all of this. Who is repeating here? So let's say k value is 1 2 3 4. From 5 onwards it's repeating, right? 5 6 7 8, it's repeating. Now so for what is the value for 1? If you remember correctly, the value is 201, and for 2 we'll just write this down, 320 132. So 320 132. Okay, and which is the starting index? Starting index is this one is 0 1 2, 3 elements, and 320 what are the indices here? 3 to 0, this is the one, and 3 to 0 is coming from 3 and 2 0 from the start. So the index is 3 2 0 from the start, that is 0th index and first index. Okay, this is first index and this is 0th index and this is the third index. Now if it is 1 3 2, what I can say, it is coming from 1 3 from here, and since 2 are already taken from the last 2, I can take 1 from here, right? See, everything is observation only. 3 is here and 0 is here. Sorry, it is second index, right? Second index, third index, and what? 0th index. So let's write down for 132. 132 is done. What is happening? Like I took 201 here, then I came back 3 2 0, 1 from last and 2 from right, and then what did I do? 2 from right and 1 from last. Then what did I do? 3 from last. So obviously the value will be what? 0 1 3. Index will be what? 1 2 3. First, second and third index. So value is 0 1 3. Can we confirm? Yes, 0 1 3 is there. Now how do we relate? We want to know this index, right? So this index is going through a rotation. So whenever you see a problem in array that is having rotation, we have a magical operator that is known as modulo. So we use the modulo operator here, but what is should be the numerator and denominator? That is the question. So what should be the denominator? Let's think, like how many numbers we want? We want 3 numbers, and how many numbers are there? There are 4 numbers, right? So if you want to rotate 4 numbers, it is n plus 1, because n value they gave as 3. Since it is 0 to 3, there are 4 numbers here, so I keep n plus 1. This is the general formula. What should be the upper value? Upper value I don't know. So for 1 or for 5, so if this is 4, if I keep 1, 1 mod 4 is 1. Okay, I keep 2 mod 4. 2 mod 4 is 2. But if you notice correctly, we can say that this is k minus 1, right? This is k minus 1. K minus 1 is 1 minus 1, 0. Now 2 minus 1 is what? 1. And similarly for 3 minus 1 is what? 2 mod 4. And this is 3 mod 4. So if you see that, this is the these are some numbers, 0 1 2 3. We got 0 1 2 3. Probably we could not relate anything, right? So index are 0 3 to 1. What is this behavior? So let's see whether we can combine something like this. See, there are many approaches. We are just trying to find out how this k value is related to here. So 0 and 0, okay, probably they are same. We'll get these 3 numbers. 1 and 3, 2 and 2, 3 and 1. So what happens is, this 1 means you are taking 1 element from here and 2 element from here. And 2 means you are taking second element, that is 2 elements from here and 1 element from here. 3 means what? Last 3 elements. So that's the logic, right? Like we are telling that if it's the fourth thing, I should take the last n minus that 3 element. So 1 represents the index where it's starting from, index where the last number is starting from. So to confirm our hypothesis is correct or not, let's take another example for 1 2 3 4 5. So this scenario is given in this question for this case 5 5 1 2 3 4 5. Now similarly, as we told earlier, how do we do it? 1, what is that MEX value? MEX value you change to 0. 2's MEX value is 1. 3, when we go for 3 it becomes 2. When we go for 4 it becomes 3, and when we go for 5 it becomes 4. So according to our hypothesis, we write 0 1 2 3 4 plus one more number, because if there are 5 numbers here, since 0 is included, 5 can come. So how do we write 0 1 2 3 4 5? This set again I am writing again 2 3 4 5. Same thing only we wrote here also, 2 0 1 3 2 0. See, 2 0 1 3 2 0 1 3. So 2 0 1 3 2 0 1 3. Similarly, I am writing 0 1 2 3 4 5, 0 1 2 3 4 5, something like that. It just keeps going, 0 1 2 3 4 5. What did we do? We have a k value of 5 that is given in the question. So how many numbers are there? N value is 5. N plus 1 means, since 0 is included, there are 6 numbers. Now what do? I say that it is 5 mod 6 is the value where I should start from the last. So 5 mod 6 is what? So if the index is this 0 1 2 3 4 5, I should take one number. So sorry, so this is k, right? K means what? K is 5. So as per our scenario, it should be k minus 1. So where is that? It is k minus 1. We derived k minus 1 to get the starting index because of 0 indexing. So if it is what? It is 4 mod 6, right? 4 mod 6. Now if it is 4 mod 6, I tell that take the last 4 elements. What are the last 4 elements? 1, 2, 3, 4. That is 2, 3, 4, 5, and add balance elements. If it is 6, I need to add only one element, right? So this is 2, this is 3, this is 4, this is 5. Only one box is remaining. So I just need to add one box, that is 0. So I hope it should be correct. So it is 2, 3, 4, 5, 0. It's correct. So we'll implement this logic. Implementation is a bit tricky, so we'll try this with the help of an example again. Now, so we have a scenario here, that is we have a vector and we have 0, 1, 3, same example. So what did we do? In order to find the MEX value, we take 0, 1, 3 and put it in an array. Then I equal to 0 to I equal to n means 0, 1, 2. There are 3 elements. I iterate through these numbers. Now what happens is this is same, this is same. Now here there is a mismatch. If there is a mismatch, I'll take the I value. That is the that is the MEX value, negative integer. That is the smallest existing. So you keep 2 here. So before that, you just have to tell that the missed value is 2. Now how to build this table? So table building is something that we will do it very easily. So we have like 3 numbers here, right? So I mean this is less than 3, and most important thing is you have to assign missed equal to n, because suppose in the question they can give 1, 2, 3 here, and missed by default can be 4. And if you keep in the question, if they give 0, 1, 2, it may happen that I value will go till 2 only. So 0, 1, 2 will be iterated through all of the t numbers, but the number 3 won't be there. So you have to write missed value as 3. So that is one important thing that you need to know for why we keep missed as n. Now coming to this point, 0, 1, 2, 3 means, first what we need to do is we need to take this number as a backup. So what is the backup value? Backup, I am putting it as 6. Then v of I, see it's all array, right? That's why. See, it's not like a table, 2-dimensional table, 0, 1, 3. So what do I do? For backup, I am pulling this number. So this number is coming here, and what happened? This missed value I already got, right? I am replacing it to 2. Now what happens? The backup becomes the new missed, because we are pretty much sure that this is the smallest value that can exist. Okay, because they told 0 to n, this is the smallest value, 0. Now this is processed. Now on the next scenario, we'll take 1. Similarly, what, right? So similarly, you just keep iterating it, and it will be simple. If you just work out, you can just get it. And at last what happens is you get 201, and the backup will be the one extra number. In this case, it will be 2013. Now what happens? K minus 1 mod n plus 1, that is the formula that we derived earlier. So the last represents how many number of elements that you need to pick from the last, so that it can be appended on the first. So if suppose in this case, if you got 4 mod 6, we say that last 4 elements need to be taken. So that's what this last represents. And what does this mean? Suppose let's say that it's 0, 1, 2, 3, 4, 5. We take the last 4 elements, right? So you got last value as 2. Sorry, last value as 4. I want to take last 4 elements. Now I need to print this, right? How do I print? That is n plus 1. There are 6 elements minus last 4. This gives the index of this element I need to start printing. So I got 2 here. So 2 is the index. Okay, 2 is the index. So I print n plus 1 minus last. I printed 2. It can go till n plus 1, that is 6. So 2 I printed, 3 I printed, 4 I printed, and 5 also I printed. Now once everything is done, only 4 are there, but we have 5 boxes. In this case, we have 5 boxes. So what we have to do is, starting from 0, you keep n minus last. Why did we keep n minus 1 last is, see, n plus 1 numbers are there, minus the same thing. That is uh, sorry, what happens is this is n plus 1 numbers. You have to subtract the minus 1 here. Why minus 1? Because there are only 5 elements that are needed. See, there are 6 elements here. I need to get only 5 elements from it. So it's like telling that I equal to 0 to I less than 5. That's all. But 5 I should not take. I already printed some last 4 elements, right? In this case it will be 4. So 0 less than 1 only. So it's like telling that you know what, I already printed 4 elements from my existing parent. I am total of 5 elements in the boxes. I need to reduce that and print from the start. So only 0 will be printed. What if it is 3? 3, 4, 5 will be printed in this here, and n minus last will be 0 and 1. 0 and 1 only will be printed. So that's all. And one more thing, important thing is, this is scenario, this is normal, okay? But in order to make it more beautiful, within single loop itself you can be able to do, like 0 to 5 you will be able to do. How will you be able to do is, see, last we know if it is 0, 1, 2, 3, 4, 5, we take the last 4 index, right? According to our scenario, what we can do is, we'll add the 0 value with n plus 1, that is then you subtract it. So that means first you print 2, then you print 3, you print 4, you print 5. Since you are taking the modulus of n plus 1, it again goes back to here and just keep printing it. How are we stopping it is, we have I less than n. Whenever the count reaches n, we will stop it. So 2, 3, 4, 5, 0. So this is also something new that you can try out. And I know it's a bit tricky, but please practice it, or please rewatch the video. So once you are able to implement, it will be very easier. And try different scenarios with the same question. I am pretty sure the last part, right, there might be very approaches. As I saw, like there are a lot of approaches to use modulos here. So that's it, guys, and please let me know if you have any comments, and see you in the next video.